Hey, Miss Marian here. We are doing Unit 3, Lesson 1. So you need a workbook. So make sure you get out your workbook, and we're going to kind of work through this and understand different things about graphs. So we're actually going to go ahead and skip the jump start right now, and we're going to go ahead and go into the rest of the stuff. So our questions for today, or like our learning goals, is how can we create a graph without equations or points given or a slope? How does the graph tell a story? And how do I describe key features of the graph itself? And we're going to be using vocabulary that we did before, and that vocabulary page should be taped in your workbook. All right, so on page 4 is where we are. It says, Sylvia has a small pool of water that needs to be emptied and cleaned, then refilled for a pool party. During the process of getting the pool ready, Sylvia did all the following activities, all these stickies, each during a different time interval. Create a story of Sylvia's process of emptying, cleaning, and filling the pool. Number the activities given in the table 1 through 6 to indicate the order in which they occurred in your story. So go ahead and pause, do that, and then come back to me. All right, so let's kind of think about which order was made the most sense for you. We actually might have different ways of actually doing this. So I'm actually going to kind of show a couple of examples all the way through this lesson of different ways we can actually order this together to make Sylvia's story. So here is the first one, and I apologize, there's a graph behind her, but let's go ahead and just ignore that for a second, and then I'll show you what the graph means. So she strained out the water with the hose. She removed water with a single bucket. Sylvia then and her friends used buckets, so all through, her friends. She took a break, she cleaned the pool, and then she filled up the pool with a hose at the same rate of emptying the pool. So this is one order that we can actually go ahead and do. Another order, here's example number 2. She removed the water with a single bucket, and then her and her friends decided to go ahead and move the water with 3 buckets. Finally drained the water with the hose because it was taking too long with buckets. Cleaned the pool, filled up the pool with the hose, and then she took her break at the end. So this is like example number 2. And then here is my example. I did remove the water with a single bucket, drain the water with a hose. That wasn't really kind of helping. So her and her friend, so 3 buckets, finally decided to empty them. She took a break, right, because it was a lot of work. She cleaned the pool, and then she filled up the pool with the hose as far as how long it took to drain it. So whatever story that you have, I want you to go ahead and sketch a possible graph showing the height of the water level in the pool over time. Be sure to include all the activities Sylvia did to prepare for the party. Remember that only one activity happened at one time. Think carefully about how each section of your graph will look. Label where each activity occurs. So you're going to have to pause on this because you're going to make a graph on your page, and you're going to graph that information. Whatever story you have, you're going to graph it on page 5. So go ahead and pause this video, graph it, and then come back to me. All right, here is the first example that I talked about before. So she's draining it with a hose. She decided to remove with a single bucket. I guess the hose broke or something. And then she decided to go ahead and do it with 3 friends. She took her break. She cleaned the pool. And then she filled up the pool. So notice how in here, this is all water level. Notice how the water level is stagnant. It stays because there's no more water in there. She's cleaning the pool with no water. Because if you ever tried to clean a pool with water in it, it's kind of hard. So notice how there's nothing here, and then finally it comes up. So pretty much my y-axis, well, a lot of these y-axis is actually water level, and then we have like a time frame on the bottom. Here is example number 2. So she removed with a single bucket, decided to go ahead and have 3 buckets, her and her friends. That didn't work, so she went to the hose. It went ahead and drained it. She is cleaning the pool, so there's no water, nothing's changing, so that during that time frame, the water level's not changing. And then she filled up the pool, and then this is where they took a break at the end. So make sure your stuff is labeled also. And then here is mine. And so single bucket, drained with the hose, drained with her and her friends, took a break, then cleaned the pool, and then filled it back up. So I guess in a way, if I really, really wanted to, I could actually label this stuff as like time, right? And then water level. Now, I don't know how that stuff was actually measured, right? But I do know what's going on with there. So question number 3, it asks us about, is this a function? Back in 8th grade, yeah, I know it was a while ago, but back in 8th grade, we talked about functions. And this is on page 5, still on page 5, right? And we're looking at our graph, and we want to figure out what a function is. You might want to go ahead and write this down because we're going to be using it for a while. So a function, okay, I'm just writing down a definition underneath the graph itself. It's I like to kind of explain it as one-to-one, meaning there's one x value to one y value, one y value. And also remember that we were looking at the x's, and we pretty much ask ourselves, are all the x values different? Is the question that we asked ourselves. And we also did, here, I'm going to move this up, I need more room. We did also what is called the pencil test, vertical line test. Right, hopefully this is all coming back to you, right, as far as what a function is. And honestly, again, I would actually draw this underneath your graph, or write the definitions underneath there, so you have it there and you can refer back to it. So the question is, you need to look at your graph and you're like, is this a function? So go ahead and answer that question on page 5, underneath number 3. All right, so this is example number 1. The question is this a function? So do I have, like, these are x values, right? These are y values. Do I have one, is it one-to-one? Are all the x values different in here? Or if I took my pencil, and I'm going to draw it as vertical lines, and we sat there and we're like, does the line only touch my pencil once? Yes. Does it only touch my once? Yes. So if I do that all the way through this graph that we have, does it only touch my pencil once all the way through? That answer is yes. So is this a function? Right? That answer is yes. Here is example number 2. Again, same kind of thing. If I took my pencil, went all the way through this graph, does this graph only touch my pencil once? Yes, it does. So is this a function? Yes, it is. And then here is my example, right? And again, if I took my pencil, went all the way through this graph, asked if, are all the x values different? Does it only touch my pencil once? Yes, it does. So is this a function? That's the question. And the answer is yes. Now, I do know that we're in a video right now, but normally we would actually share our story. And if you and your partner are kind of at the same spot, you can actually say, hey, you know what, let me show you my example. But it's okay if you don't. But remember that we can have different examples for the sticky notes that we have. And are all of our examples correct? Absolutely. It's just kind of showing different things. And what we really are looking at, is this a function? We're also going to be looking at some other stuff too. So we also need to figure out, what is the x intercept? What is the y intercept? What is the maximum? What is the minimum? And so on each of the graphs, we can actually go through all these different things. The maximum is, where does it start? Where is the highest water level? Well, that's as far as what we actually put. We don't have numbers on here, but is there a minimum? Well, the minimum is we emptied that pool, right? So the minimum is actually 0. because we empty the pool, there's no water, and everything's kind of relative to the water level. That's how they asked us to go, sorry, to go ahead and answer this question is the water level. We're looking at that water level. Where is it sitting? Where is it working at? And that's what we're looking for. And again, we labeled all of our different stuff. Does the pool empty and fill at the same rate? How is your rate of change? But again, we weren't giving numbers on this. I mean, we could put numbers on there as far as figuring out the rate of change, which is the same as the slope, right? But yeah, so during this whole entire unit, we're going to be looking at graphs. We're going to be understanding graphs, and a little bit more than what we did in 8th grade. So again, some more questions. How long does the whole process take? What are the different heights of the water? Where is it in there? So how long does it take the whole entire process? The domain, how long did it take the time process itself? Again, when we had actual labels, we'll be actually to define this more. But again, this is what we're looking at. So again, one of the takeaways, we need to make sure that you have your vocabulary. We actually did this earlier. There is a vocabulary page. It should be in your basket if you don't have one. But we are going to be covering all this vocabulary, and it should be taped into your workbook already. But we're going to be talking about all of this during unit. So x value, x-intercept, y-intercept, maximum, minimum. Where does it increase? Where did it decrease? What is the rate of change or the slope? Domain are all the x's, range are all the y's. Is it discrete, continuous, and discontinuous, right? So we're going to be talking about this. Make sure you have that vocabulary in there because, again, it's very, very helpful, okay? One of the things for your homework that we're going to be doing is you're going to be graphing this f of x kind of stuff. And part of the stuff we haven't really gone over, but I'm going to go over one little thing really quickly. F of x is a fancy way of saying y equals 3x plus 5. So what's called f of x and g of x, they're just showing that we have two different equations here. So we can go ahead and graph that. If we look at this piece of information, my slope is 3/1, my y-intercept is 5. And so if I was looking at this here, I'm going to go ahead and put my x and y-axis on here because I don't have one. So if I was graphing f of x, or the red stuff, my y-intercept, let's move that over. Sorry, my y-intercept is 5, so we're going to go up to 5. 1, 2, 3, 4, 5. We're going to put a point at 5. That's where we start. That's where we begin. That is my y-intercept. That's where it crosses the y-axis. And then from here, we're going to use our slope. We have positive 3 for our y's, positive 1 for the x's. And then this is how we graph this line. Okay. Now the other equation, again, it's just another fancy way of saying, hey, I have another equation. Here it is here, right? And then this slope is negative 3/1. The y-intercept is 5. So we're going to go up to 5. And I'm going to go down. So my vertical is down, or negative. So it's a negative slope. It goes down the hill, right? So notice how it's 3/1. And I can do it one more time. And I can go ahead and graph these. So f and g of x is just a way of saying, here's an equation of y equals mx plus b. Let's go ahead and graph it. And you have a question on your homework. So that's what I want to make sure we actually went over this and understood it. Really quickly, let's go ahead and solve an equation for x. So this is the retrieval part. It's part of your homework area. With equation A, both sides are crowded. Does it matter which sides we move first? No, it does not. I'm just going to go ahead. I'm going to add 5 to both sides because I know I can do that. And then what's left over, 3x. 5's go away because it makes it 0. Still have 2x. Negative 4 plus 5 is a positive 1. Then this x guy, he wants to be over here with his friend. That 2x is positive. How do I move it? It's subtracted off. So we have 3x minus 2x, that is 1x, equals 1. If you need to, you can still divide by 1, so x is 1. And this is also part of your homework, so I want to make sure we understood it. All right, so today we went ahead and we went over graphs. We just described different things of graphs. We made a graph and then kind of compared it to a story. And make sure you go ahead and do your ready, set, go as far as practice problems at the end of lesson 1. Have a good day. Thanks. Bye.